Hey, what's up, guys? Welcome to Lesson 9. This is Module 3, and today we're green. I'm just trying to mix it up a little bit. Go with the softer color, see how it works. Um, Today we're going to be kind of doing away with the fraction models as the rectangles, and instead we're just going to be using we're making like units as far as it goes with our numbers. So. We're kind of just extending what we've been doing, and I don't think it should be too much of a stretch for you guys. I think you should be able to do this pretty well. So let's start off. I have a problem, which it was let's do 1/2, and we're gonna add that to 1/5. Okay, and so what I want to do is over here, I'm gonna do myself a picture and do like we've been doing, and over here I'm just gonna do things numerically, and so you'll see how this works. Okay, so first what I would do is with this I would take my 1/2, and previously we would just draw a rectangle for my 1/2, and we would draw a rectangle for my 1/5. I would diagram this out as 1/2, so I would put it into two pieces, and I would shade in one of those pieces. Okay, so that's my 1/2. And over here I would make fifths. Got 4 lines to make my fifths, and I would shade in one of those sections. Okay, and so that's where I would start, and I'm gonna line that up over here. So I'm gonna say I have 1/2 and I have 1/5. I'm gonna give myself a little space on here for a reason. So now what I would do is I would then say, well, I need to make these similar. I need to make them like pieces, like sizes, because I can't just add this to this. It doesn't jive. It's not the same size piece. So I would take my fifths, and I would excuse me. I would take my fifths and I would draw my line. Bing. And what I just did with that was basically I doubled it, didn't I? I took this and I doubled the number that was there. I had one shaded in, and I cut that 1/2 to make 2. I had 5 pieces total, and I doubled them to make 10 total, right? And so what I did was, I'm going to write it over here. I had my 1/5. I can do a better line than that. Sorry. What I did was I doubled it, right? I multiplied each by 2. I doubled. I had my 1 shaded, and now I have 2. And I had my 5 total, and now I multiplied that. And so I doubled both of them. 1 doubled, or times 2, is 2. And 5 doubled is 10. And so, according to my math, now I have 2/10. And over here, if I count them up, I have 1, 2 out of 10 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 2/10. And let's take a look at what I did with my half then. I have my half. If I'm adding these up, I needed to make these into fifths, so I put my half over here, and I got to put my fifths over here. So I'm going to draw 4 lines, right? 1, 2, 3, 4, and I have 5 sections. 1, 2, 3, 4, 5. What I did was I took that half and I multiplied them by 5. I took my half, my shaded in section here, which was 1, and I cut it into 5 pieces, and now I have 5. So I had my 1, and I multiplied it by 5. I had my 2 sections. I had my 2 sections, and I multiplied those guys by 5. See, I cut it into 5 sections, both of them. And so 1 times 5 equals 5, and my 2 times 5 is 10. So over here I have my picture that I drew, and over here I have numerically represented the way that these pictures look. So I have my 1/2, which turned into 5/10. I have my 1/5, which turned into 2/10. So now I can take my 5/10, I can add my 2/10, and I can get 7/10. All right. So that's just kind of the basics. This is what we're going to be focusing on here, is how to represent this numerically with numbers. So let's go ahead and try a different problem. Let's try problem 2. let's make this 1/2. And we're going to add, instead of 1/5 this time, we're going to add 2/3. And so just some basic things. If I look at this problem, it's different because on this one I'm adding 2/3 instead of 1/5. And 2/3 is definitely bigger, and it's bigger than 1/2 even. So if I had to take a guess, when I add these two up, I know that my answer is going to be greater than 1. So what I want to do now is, I don't want to draw out that rectangle. I just want to imagine that rectangle in my mind. And in my mind I have my half, I have my rectangle drawn, and it's in 1/2. And then I'm going to go about, I'm going to take that and I'm going to cut that into thirds, right? And so ultimately what I'm doing is I'm taking my half, I'm going to draw it longer here, I'm taking my half, and I'm cutting it into thirds, right? I'm making 3 groups within that half. I am multiplying each one by 3. I'm multiplying the top, the shaded part, that one that I have, I cut that into 3 pieces, and that's right here. And the whole thing, the 2, I multiplied that into 3 pieces, didn't I? So let me go ahead, and I will draw this out, just so you can see this. I'll do it in white, so it's going to stand out differently. This was my half, right? That was my half. And I multiplied, because I had to do the same thing to each side, right? I had my thirds. I had to cut this one into 3 pieces as well. And so I have thirds. Now, I multiplied, I partitioned them up into thirds, and I multiplied my half by 3. Okay, so when I do that, now I had my one shaded section, and now I have 3 pieces in that shaded section, right? That would have been this. And I had my total pieces were just 2, but I multiplied them into, I multiplied it by 3. I cut them into 3 sections, and so now I have a total of 6. If I'm doing the same thing then to my 2/3, I'll do that over here. I'll do 2/3. Make my line longer. What I would do is I would have my 2/3, and I would shade those in, and then I would come over and I would cut them in half to double it. And so I would end up taking both of these and I would multiply them by 2. I would double them, because it was, let me show you, it was this, and I had 2/3, I had 2 of these shaded, and then I came along and I had to double them. I doubled them with that line, and that doubled it to make the size of the pieces the same so that I could add them. And when I doubled them, I just multiplied them by 2. So I had my 2 pieces, I multiplied that by 2, and now I have 4 total shaded pieces. And the total pieces that I have altogether, I have 6 altogether. So now we can just we see this numerically represented here. I'm going to clean it up and I'm going to write it all down here. I'm going to say I had my 1/2, and I multiplied each by 3, and I added that to my 2/3, which I multiplied by 2 or doubled, in order to get 3/6 plus 4/6, which would give me a total answer, a total sum of 7/6. Now 7/6 can be broken down, we'll do this up here, 7/6 can be broken down into 6/6 and 1/6, or 1 and 1/6. And that would be my sum. Okay, let's keep going, let's keep trucking here. This next problem is going to have 3 fractions that we're going to be adding: 2/3, and we're going to add 1/4, and we're going to add 1/2. Now, does this affect the approach that I'm going to take to this problem? Well, no, not really. I know I need to put them all in the same size piece. So what I'm really looking for is a multiple of all of these three numbers. What numbers do these share? To visualize that, if I just counted up by these numbers, right? If I did 2, 4, 6, 8, 10, 12, 14. If I did, let's do the 4. If I did 4, 8, 12, 16, and if I did 3, 3, 6, 9, 12, I can see that all of these share that 12 as a multiple. And so I know that that 12 would be a good one for me to use when I'm doing this problem. If I had to cut all those into pieces that they could share, that I could share around, let's say somebody brought 2/3 of a cake, somebody brought 1/4 of a cake, and somebody brought a half of a cake to a party, and we were going to all make sure that everybody got a fair piece of that cake, of all three of those cakes, we need to cut them into the same size pieces, and we determined that that would be 12, okay? And you can do that by several ways. You can do like what we just did. You could take a look at the numbers and think to yourself, what kind of multiple do they all share? You could multiply some. You could do 3 times 4. You could take the two biggest ones. I could do 3 times 4. 3 times 4 is 12. And as long as that was shared by the 2, I'd be good to go. So definitely different ways that we could do that. Either way, we're dealing with 12ths, and that's where we want to go. So I'm going to put that over here, okay? We're trying to get to 12ths. So if we take our 2/3 and begin with this, how can I turn my thirds into 12ths? Well, same way we were just talking about. I'm going to multiply my thirds. I'm going to do that by 4, right? And if you had to, if you were taking a look at this, you would say to yourself, I have my rectangle, and my rectangle was shaded 2/3, right? On my 2/3, and if I did it with fourths, then I would draw 3 lines. I would split it into fourths, going the other way, and I would have a total of 12 pieces, right? And so all we're doing is mathematically representing this. We're saying 3 times 4 would give me my 12ths. And I split it into 4 pieces. I split the whole, but I also split that shaded part into 4 pieces. And so my 2 times 4 would be 8. And so my 2/3 becomes 8/12. Those would be equivalent fractions. Awesome. Let's do the fourth then too. Let's do my fourths. Okay, I have fourths, and I need to turn it into 12ths. I know that if I was just doing, like I said, I would split it, my fourths, I would draw it the other way into thirds to get 12ths. And so I'm multiplying each one by 3. I'm tripling it. 1 times 3 is 3. So my fourth becomes 3/12ths. And last but not least, I have my half. And how do I turn my 2 into 12ths? Well, we can do the same thing. Let's say I have a half. Let's say I have my half box that I drew, and I'm going to split it into, let's say I need to get it into 12ths. So what am I going to split it up into? What's the way I'm going to do that? Well, 2 times what is 12? And I would know that I need to split that up into sixths. So I would do my 2 times 6 would be 12, and my 1 times 6 would be 6. So now I have all 3 of these that I can add up. I can add up my 8/12ths plus my 3/12ths plus my 6/12ths. And I can get 8 and 3 is 11. And 11 and 6 would be 17. And so I would get my 17/12ths. Well, I could split that out. I know 12/12ths is 1. And 12/12ths plus 5/12ths would equal 17/12ths. So I would have 1 and 5/12ths. And that would be the sum, okay? So let me summarize what I did here. We took all 3 of these, and we tried to figure out what they shared as far as their denominator goes. We went over 3 different strategies, or several different strategies that you can use to come up with that they all shared a multiple of 12. Then what I did was I figured I had 2/3, and how did I turn my thirds into 12ths? Well, I split it up into fourths. So I multiplied the top and the bottom by 4 to get 8/12ths. I did the same thing with my fourths. I multiplied it by 3 because I have my fourths. I need to turn my fourths into 12ths. And the way I did that was by multiplying each by 3. Essentially what I did was I I divided it going the other way with the lines to get by 3 to get my 12ths. And my half over here, I did the same thing. I multiplied by 6. But the half wasn't so easy for us to figure out because if I just had my half, it wasn't like I was doing either turning it into fourths or thirds. We needed to figure out, well, how could I turn my half and get that to 12ths? And we realized that I needed to partition that off into 6 different pieces. 2, 3, 4, 5, 6. Okay? I got all of those. I added them up to get 17 twelfths, which I split off into one whole was 12 twelfths, and I had 5 twelfths left over to give me a sum of 1 and 5 twelfths. Awesome? Okay, let's do one more. This last one is going to be 5 ninths plus 5 sixths. And this one is different in that we're dealing with some bigger denominators off the bat. All right? We're not dealing with halves or thirds. We're dealing with ninths and sixths. And so what we're going to want to do is take a look at what could be our possible common denominator here. Traditionally, what we would have done is we would have done this, and we would have put that, let's say, into eighths, and then I would have put that into 6, 2, 3, 4, 5 to get a total of, well, 9 by 6 would be 54, right? And then we would deal with 54ths. It's pretty big. We don't need to do all that work. Because both of these share multiples that can be bigger pieces. What do 9 and 6? What do they have in common? What multiples do they have in common? I could do 6, 12, 18, 18, because I know that 9 and the next one is 18. I know they share 18. So we don't have to do the 9 times the 6 to get 54ths, because those are teeny tiny little boxes. We can make both of these just into 18ths, and that would be quite a bit bigger. So how do I turn that into 18ths? How do I turn it into 18ths? Let's get my 54ths here. Let's get rid of this. And say, let's say I do have a 5 sixths, okay? And let's do 2, 3, 4, 5. I have 5 sixths, and I need to turn my sixths into 18ths. What would I do? How can I turn my sixths into 18ths? Okay, and so that's ultimately what we're going to do. We're going to try and figure out using numericals instead of this old jazz right here how to make that happen. So let's take a look. Let's do our 5 ninths first. Okay, let's do 5 ninths, and I want to make that into 18ths. If I had that 9, I know all I'm going to do is double that to get to 18. So then I'm going to double the number that I had shaded in, double my numerator here, and 5 and 2 would be 10. I would have 10 18ths. My 5 sixths, doing the same thing. I'm multiplying it by what to get to 18? Well, here it was, and I know that if I want to get 18, I'm going to have to do that to get, I'm going to split it into thirds here in order to get my 18ths, right? Because 6 times what is 18? 6 times 3 is 18, right? 6, 12, 18. So if I'm multiplying the bottom by 3, I got to multiply the top by 3. 5 times 3 would be 15, and I have my 15 18ths. So now I'm just adding them up. 10 18ths plus 15 18ths equals, that would be 10 and 25, 25 18ths. I can split that out. I know that 18 18ths is 1, and 18 plus 7 18ths would be equal to 25, and so I know that that's 1, 7 18ths, okay? The big learning, the big aha on this one was that we don't necessarily have to just multiply my 9 by my 6 to get 54ths. Sometimes that's not necessarily the easiest way to do things. If we can find a multiple that's lower, if we can find it and make it a fraction, ultimately the fraction size is bigger. If we can do that, it's going to make our lives a little bit easier. It's an important side note to say that could you do it as far as 54ths if you really wanted to? Yeah, you really could. And maybe I need to prove that down here. If I did 54ths, let's do 54ths. If I had 5 ninths, well, how do I turn that into 54ths? I know I'm multiplying it by 6. So let's multiply both by 6. 5 and 6 is 30. 30 54ths. That's what that would equal. And if I was doing that, I would need to do the same thing with my 5 6. So 5 6 54ths. I'm going to multiply it by 9 to get 54ths. So I'm going to multiply the top by 9, and 5 and 9 is 45. So now I'm going to add these two up. I got 30 54ths plus 45 54ths. And 30 and 45 would be 75 54ths, right? Okay. And I know I can split that off into 54 54ths. And now I'm going to need to do some quick subtraction here. 75, take away 54. 5 minus 4 is 1, and 7 minus 5 is 2. So that'll leave me with 21 54ths. Okay, awesome. And I know that I could turn that into 1 and 21 54ths. And then it's just a matter of simplifying this guy. I have 1 and 21 54ths. Well, I can see it's 7. Does 7 go into 54? No, it's 56. 3 would go into both of those, wouldn't it? 3 goes into 21 how many times? 7 times, right? How many times does 3 go into 15? 18 times. And so then I could simplify it down to get my total sum of 1 and 7/18ths like I did up here. So ultimately it doesn't totally matter. You can see how in the end, doing it this way up here, finding the 18ths, helped save me some time so that I didn't have to do it with the 54ths and then simplify and do all of that. But ultimately, you could do it any way you wanted to get it to the same size pieces. You can multiply both by, I don't know, to get whatever it is to get to your shared thing. So you can multiply them both by each other. You can get to it however you need to get to it. Okay. I feel like I was a little rambly today. Maybe the green was making me rambly. I'm not sure. Hopefully this was helpful to you. I rambled on for 22 minutes. The longest one in a while. If you made it this far, you're awesome. You are my favorite student by far, and definitely the best looking, and you are just like super cool. Good job. Good for you. So thanks seriously for watching. It means a lot to me that you're taking the time to do this, and it means a lot to me that your math means this much to you. So keep up the hard work. You're doing really well. The fact that you've made it this far means that you really care, and that's just like half the battle in life if you just care enough to try. So good job. Post any questions, comments.